Don't forget to like and subscribe or I'll come to your house and slap me bum.
This is a video about emergency call out and minor electrical fire. He called last night because there's been a burning smell. National Grid had been out. They said, you know, you need to get an electrician out. They didn't really look at it. They just looked at their bit, they cut out and that's it. So then this apartment downstairs here had no power. And like I said, there was a burning smell in here. So this is what we came out to last night, but I didn't have the equipment to replace it last night at like 11 o'clock at night. So I've had to go out, find some gear this morning, which has also been difficult because I don't like to fit what I class as cheap crap. So all wholesalers now stock this budget shite equipment, and if you want to get anything in stock, it's like next day or whatever. So I had to call 7 different wholesalers this morning to try and find one that had the item in stock that I wanted off the shelf same day. Everyone can get it next day, but no one actually stocks decent stuff. A few days ago, I went to a call out, which again was a failed isolator and that had almost caught on fire. So, and it had only probably been installed a few years. It looked quite new. So it wasn't even an old piece of equipment. No connections were loose or anything like that. It was just the failed mechanism inside the main isolator, the 100 amp isolator. So I go to a lot of call outs with these failed 100 amp isolators, a lot. And like I say, this specific one here, again, is this budget range of gear that everyone stocks that I choose not to fit. So I'll show you the gear that I've got in a minute, but I'll just show you what we found last night and you know what we're gonna have to do now, and my suspicions as well as to why this has happened, because I don't think this is a failed piece of equipment here. I think this is a case of an overloaded cable and fuse. So I had a quick look inside, and my suspicion was because it was a Proteus equipment, which, you know, that's an old make that, and it was a decent one in its time. I don't know if they still manufacture them now. So when I went to look at that, my first suspicion is it's not cheap gear. The connections were tight. So I was like, I don't think that's failed equipment. I think that's an overloaded fuse and an overloaded cable. So from this main cutout here, you've got a 10mm armoured cable. So you've got a 3-phase supply coming in and a phase per flat, and then a 10mm armoured cable going out to the flat. Now, I would fit as a minimum a 10mm cable to an outbuilding, or to a summer house or a garden office or whatever you want to call it. The minimum cable I would fit to that would be a 10mm. This has got a 10mm cable supplying an entire apartment, which is all electric, heating, water, cookers, induction hob, oven, everything, lights, sockets. So my first suspicion, don't know, I might be wrong, is that cable cannot carry the load that's required, and the 63 amp fuse protecting it is completely overloaded, has got hot and caught on fire. So we're going to get this unit changed over, get the power back on, and then I'm going to go in the house. We're going to switch some stuff on, do a load test, and then check what load that the apartment is pulling. An electric boiler to do a whole apartment would normally be between 10 and 14 kilowatt, I'd say. So if it's 10 kilowatt, the cable supplying, the circuit supplying the boiler alone is a 10mm cable, because that's the kind of load that it's pulling. And this whole building's got a 10mm cable supplying it. And she did say last night she was cooking. So if the heating's on, the hot water's trying to heat this tank up, and she's got the induction hob on, she's probably pulling way over 63 amps there. So that might be the reason why this has worked itself. You know, it doesn't just happen overnight. It's probably got hot plenty of times, and it's just happened to have failed last night. So I'll look around and show you what we've got. You've got all these armoured cables that go off to the 3 apartments. You've got your 3 switch fuses, which is great. 3-phase supply coming in. There's 2 meters here for this one isolator because they were worried about some false readings or something, so they put 2 meters on it just to make sure that they were running and clocking up the same mileage, if you like. So that's why there's 2 meters, so it comes out of there to this, and then from that to there. So we've got one supply. Yeah, what do they say on them? It says 100 amps. So that's what we've got here. 60 mil tails out there. Meters for 2 of the units here. This is the one that's melted. There is the fuse carrier. So it's not blown the fuse. It's just melted the fuse carrier. So that suggests that this has been running way over 63 amps, because these can take more than 63 amps before they'll blow of load, especially if it's through at short periods of time. So if they're using the heating and the oven for like 20 minutes, this will get extremely hot and not blow if it runs like 10-20 amps over. So that's why these can get hot and not blow. It just depends. If it's fault current, it'll blow it quickly, yeah. But if it's overload and it's just, you know, just over by 10 amps or whatever, which is a considerable amount, it can just get hot and not actually blow the fuse. So that's looks like what's happened here. So you've got inside there is all melted. Inside there is all melted. I've had this cover off the side of the switch, is all melted. And the top there, you can see there's no grommets used. There's no grommets used on either of these. And you can see some browning of the cables on the top there. There. So there's already some browning there that I think the guy from National Grid highlighted. So you got unprotected tails going through a metal enclosure, no grommet, overheating, and this inside. So let's whip this off now. I can see it a bit clearer now there. So you got the burnt. And as soon as you got the overheating at the side there, but the overheating of that isolator there will have come from this connection here. So yeah, we're gonna whip this off and get it replaced. And then get the power back on. So yeah, this is only a skinny 10 mil cable that. I'm just dismantling this now. See, that is absolutely brittle. So that's took quite a while to get the insulation to that state of overheating. It's not something that just happens quickly. And then I've just popped this gland off and just look at that. I've not undone that nut, anything, just, that's not even glanded off into there properly, so. All signs of a shit job. So this is the kind of thing that I like to fit in a domestic, single phase, 100 amps, 60, 80 or 100 amp situation. So it's a nice big metal enclosure. It's really good quality, absolutely rock solid, really heavy. Great for glanding armoured cables off into it because the frame doesn't bend out of shape. It's not like a flimsy little tin construction. It's a really very good quality external enclosure. So like I say, great for big cables entering it and stuff. You got this whole isolator unit which is fixed, solid. It's not just a little standard 100 amp isolator just clicked onto a DIN rail, getting bent out of shape because people have made the armoured cables or made the tails off wrong into it, and it, they're under too much tension and it's bending connections out of shape. This thing is absolutely rock solid. So you've got this huge 100 amp connection. You've got these little guides and then covers that go over the tails there to clamp round them. It's Allen key connections. It's got doubled up connections there, so it's nice and long. You get nice tight connections. You've got this changeable fuse, so you can put a 100 or 80 or a 60 in it. So it's just a really high quality isolated switch fuse. It's quite big compared to that one. It's considerably bigger, but it's just much better quality. And this is the kind of, if I'm fitting a switch fuse in a house, sort of in a domestic premises, this is the things that I would rather fit, unless it was a space issue. But this is the go-to that I would always use. Just found out why this armoured cable was made off so badly, so I've just stripped some of it back so we can take this damaged cable off. Just about to put this on, and just realised that this is supposed to have another nut on top of that. This is the outer nut which gives it its IP rating. If it was, this is an external rated gland, so they've used the final external rated gland there that hasn't got the actual copper ring inside that closes down onto and grips the steel wire. So I don't know what they were thinking here, but that's why that was made off so badly anyway. Right, so here's this fitted now, and this is temporary because we need to upgrade the supply. So the armoured gland, because we didn't have an armoured gland and it's got a separate earth and the armoured cable is completely on show, we can get away with not our earth in the sheath this, you know, for now until we come back and change it. So just stuff some new tails in here because they were all burnt to the meter. A 60 amp cartridge fuse in there, tail gland in it. As we've seen, there's holes in the top of these here, and then this just connected into there for now. So I'm just going to power this up and then run some stuff in the flat and then see what load this is pulling. So what we found out about this place is the apartment next door used to be the hired venue. So it just had a few electric radiators and a few lights and sockets and things. Then it's been converted into a living space. So so it had this 10mm armoured cable would have done what it was, you know, what it was used for before. That would have managed. But since then, it's had induction hob, oven, washing machines, dryers, electric central heating system, you know, electric water heating system. So that 10mm cable is nowhere near big enough. That 63 amp supply is nowhere near big enough to deal with what's going on in there. So when you're installing electric boilers and things like that, electric car chargers, you're supposed to calculate this stuff before you go installing huge appliances like that, huge current using equipment. The plumbing company that installed the boiler have just come in, installed it, and not looked at what the main supply can handle, not looked at any of this stuff, and then this has happened. It's not fit for purpose anymore. So when the building was refurbed, this armoured cable should have been upgraded, but it's never been. So it needs a minimum 80 amp supply, I'd guess, but we're going to go in and do some measurements in a minute. Also, you've got another 2 flat apartments, which are also, one of them's got a boiler and one of them's all electric. So I said to the owner, we need to do a load check on these as well and make sure these are not strained, you know, and they're running at absolute maximum capacity for safety in future. So that's running at 66 amps. So this is just central heating, hot water, couple of rings and the oven, which is again not out of the ordinary for them all to be on at the same time. So that's running at 65, which you've just seen then, 66 amps. If we have the washing machine on and a few other things, that will be pulling, you know, 75 amps. So if that's been running at that sort of ampage for, you know, over a long period of time, that's the reason why that unit has deteriorated and overheated, become brittle and burnt and caught on fire. So it's been inside now, turned everything back off, put the consumer unit back on. So the actual boiler circuit itself is a 50 amp circuit, and the capacity of the supply to the house was 63 amps. So that just leaves 13 amps allowance for a hob, an oven, all the plug sockets, you know, the appliances plugged into them. So it's not enough. That should have been, you know, took into consideration when, you know, when the boiler was added, basically a massive 50 amp circuit added to the consumer unit. So it still took a very long time for that to happen though. So that took 3 years for that getting hot, and then eventually getting to the point of catching on fire.